Hi viewers, this is Panikmar, Senior Lecturer in Chemistry in Narayana Group of Institutions. In this video, I would like to start the easiest topic of plus 2 chemistry, that is p block elements. Alright, before starting the concept of this day, I would like to ask you a question. Try to remember. I will tell you the answer, right? So in the long form of the periodic table, based on the differentiating electron, the long form of periodic table is classified into how many blocks? Just try to recall once. We know that the long form of periodic table is classified into 4 different types based on the differentiating electron. They are S block elements, P block elements, D block elements and F block elements. Regarding the S block elements, already you have studied in the +1, right? Next, regarding P block elements, what are P block elements? And regarding P block elements also you have studied already in the +1, 13th and 14th groups you have studied. Okay, whatever it is, let us have a small review on the long form of periodic table. How the long form of periodic table is classified into 4 different blocks. And let us start today's class, right? So we know that based on the electronic configuration, the long form of the periodic table is classified into 4 different blocks, right? What are they? S block elements, right? S block elements. These are present in the extreme left hand side of the periodic table. And next, P block elements. These are present in the extreme right hand side of the periodic table. And D block elements, these are present in between the S block elements and P block elements. And for our convenience, we have placed F block elements at the bottom of the periodic table separately. These are the F block elements. This is what the classification of the long form of periodic table based on the differentiating electron, right? If the differentiating electron enters into the s orbital of the valence shell, that means s orbital which is present in the outermost orbit. If the newly added electron is added to the s orbital which is present in the outermost orbit, right? Which is present in outermost orbit, which is called as valency orbit or valency orbitals, we can say, right? So if it is added to the s orbital, simply they are called as the s block elements. They are called as s block elements. We know that an s orbital can accommodate a maximum number of 2 electrons. How many electrons an s orbital can accommodate? It can accommodate only 2 electrons. So S block elements, the S block is classified into 2 different groups. What are they? 1A group elements and 2A group elements, right? Next, if the differentiating electron enters into the p orbital of the valence shell, p orbital of the valence shell, then those elements are called as the P block elements. Those elements are called as P block elements. We know that a p orbital can accommodate a maximum of 6 electrons. So here in p orbital we are having 6 different groups are there. In p block, how many groups are there? As a p orbital can accommodate 6 electrons, P block is having 6 different groups in that. What are they? Here we can say third A group elements, next 4th A group elements, 5th A group elements, 6th A group elements, 7th A group elements, right? And the last one is 0 group elements or 8th A group elements, right? Next, if the differentiating electron enters into the d orbital of penultimate shell, if the differentiating electron enters into the d orbital of penultimate shell, right? That means n minus 1 d orbital, the shell which is present before the valency shell, is simply called as what we can say the penultimate shell. If the differentiating electron enters into the n minus 1 d orbital or d orbital of the penultimate shell, then those elements are known as d block elements. Here, based on the n minus 1 d orbital, we are having 4 different series of d block elements: 3d series, 4d series, 5d series, and 6d series. And if the differentiating electron enters into the f orbital of anti-penultimate shell, that means the shell which is present before the penultimate shell, that is n minus 2 f orbital, are known as the f block elements. Here there are 2 different series of elements are there based on the f orbital: 4f orbital and 5f orbital. Like this, we can classify all the elements into 4 different blocks based on the entry of the differentiating electron into the orbital. Okay, here if you see in s block elements and p block elements, okay, in s block element and p block elements, the differentiating electron enters into the valency shell. Here the differentiating electron enters into which shell? That enters into the valency shell. That means outermost shell. That is why the groups that are present in the s block and the p block are designated as A subgroups: A, 1A, 2A, 3A, 4A, 5A, 6A, 7A or 8A. Like if here in d orbital, what happens? The differentiating electron enters into, in d block, the differentiating electron enters into the penultimate shell. So the groups that are present in the d block are designated as B subgroups. They are designated as B subgroups. This is what you have studied in +1. If we want to discuss about the position of these blocks in the long form of periodic table, we know that the S block elements are present in the extreme left hand side and P block elements are present in the extreme right hand side, and the D block elements are present in the middle of S and P block, and F block elements are placed separately at the bottom of the periodic table. Right. Now we are going to discuss about these P block elements now. So here in the P block elements also, in +1 you have studied about the 13th group elements or 3rd A group elements and 14th group elements or 4th A group elements. Already you have studied in +1. And now we are going to discuss about the 15th group elements or 5th A group elements. What we are going to do in this video, we are going to discuss about the 15th group elements or 5th A group elements. 15th group elements or 5th A group elements we are going to discuss in this video. So here, as I told, here we can write two different names for these elements. 15th group elements. This numbering is given according to the IUPAC system. According to IUPAC system of assigning numbers to the groups, we have to assign the English letters right from 1 to 18 or assigned in the long form of periodic table. And now here 15th group elements, or if we represent this one in the Roman letters, 50A group elements. Okay, 50A group elements. Okay, so why these elements are referred as 50A group elements? Why these elements are referred as 50A group elements? Or is there any other name for these elements? Means these elements are also known as Nicogens. These elements are also known as Nicogens. What are Nicogens? What does it mean by Nicogens? Means simply the inhalation of the gases produced by these elements will cause some suffocation. As they are suffocating, these are simply called as the Nicogens. Right? Are you clear, students? Okay, let us see. So here, what are the 50 group elements and what are these 15th group elements? I think all of you know nothing but nitrogen, phosphorus, arsenic, antimony and bismuth. What are the 50 group elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. What is the atomic number of these elements? You know. What is the atomic number of nitrogen? 7. I think students, you are all very much familiar about this. It is very simple to remember the atomic numbers of the elements if you know the atomic number of the first element in every group. So here we know that in the next group we are having, in the next period we are having 8 elements. Okay, if you want to write the atomic number of the element which is present in the third period, what you have to do? You have to add 8. So 7 plus 8, 15. And in the third period you are having 18 elements. So 33. 15 plus 18, 33. Plus 18, 51. And plus 32, 83. So we know that in the long form of periodic table, you know, the first period is having 2 elements. Second is having 8 elements. 2 plus 8 plus 8 plus 18 plus 18 plus 32. So here nitrogen is in second period. So if you want to write the atomic number of phosphorus, you just add the number of elements in the next period, 8. So you will get 7 plus 8, 15. Right? Now to get the atomic number of arsenic, 15 plus 18, 33. Next, to get the atomic number of antimony, 33 plus 18, 51. And to get the atomic number of bismuth, 51 plus 32, 83 you will get. This is what about the atomic numbers of these elements. Now let us see, this is element, this is the atomic number. Now let us see about the nature of these elements. Let us see about the nature of these elements. So that means we know all the elements in the long form of periodic table are classified into 3 different types based on the tendency of that element to lose or gain the electron. All the elements are classified into 3 types: metals, non-metals and metalloids. Metals, non-metals and metalloids. Here the first 2 elements, that is nitrogen and phosphorus, are the non-metallic elements. These 2 are non-metallic elements. Nitrogen and phosphorus both are the non-metallic elements. Okay, next arsenic and antimony are the metalloids. Arsenic and antimony are the metalloids. Next, the last one, bismuth is a typical metal. The last one, bismuth is a typical metal, right? It is a metal, right? Now, if we want to discuss about the physical state of these elements at STP conditions, what will be the physical state of these elements at STP conditions? Physical state. What will be the physical state of these elements means simply the first nitrogen at STP it exists as N2 gas, nitrogen, N2 diatomic nitrogen. It is a gas. The first one, nitrogen, is a gas, and the second one, phosphorus, is a sublimable solid. It is a sublimable solid. What does it mean by sublimable solid? That means the solid which is having the tendency to get converted into the gas state directly. Generally, if you have taken water, what happens? If you take ice, what happens? If you heat ice or if you place the ice in the atmosphere, ice melts and gives water. If you boil water, that will be converted into gas. Generally, in the transmission of a substance, what happens? Solid converts into the liquid, liquid then converts into the gas. But here it does not happen. What happens? The solid substance directly converted into the gas without intervening the liquid state. Such a kind of solids which gets converted into the gas state directly are simply known as the sublimable solids. And the next three, arsenic, antimony, bismuth, these three are the solids. The next three are the solids itself. So this is what about the physical state of these elements. Next, if we have taken the atomicity of these elements, what does it mean by atomicity? All of you know. Atomicity means the number of elements present in its molecule. So here, generally, nitrogen atomicity is 2. It exists in the form of diatomic nitrogen. Next, phosphorus, arsenic and antimony exists as tetraatomic molecules. So, their atomicity will be 4. Generally, we don't discuss about the bismuth atomicity because it's a metal. Okay, it forms a metallic solid, right? It's a pure metal, right? So, we cannot, we don't discuss about the atomicity of the bismuth over here. And next, if we have taken the conductivity, that means thermal conductivity or electrical conductivity, whether these elements are having the ability to allow the electricity to pass through them or they don't have the ability to pass the electricity or heat means, that is simply, I will tell you in terms of conductivity. The first two elements, that means what are they? Nitrogen and phosphorus are the poor conductors of heat and electricity. The first two elements are poor conductors of heat and electricity. And the next one, arsenic will be a semiconductor. Arsenic will be a semiconductor. Arsenic will be a semiconductor. And antimony and bismuth are the good conductors of heat and electricity. And next, here itself I told 50A group elements. Why these elements are called 50A group elements means the general electronic configuration of these elements will be NH2 NP3. The general electronic configuration of these elements in the valency shell will be NH2 NP3. Let us see whether it is correct or not. So here, electronic configuration of nitrogen 1s2, 2s2, 2p3. What is the electronic configuration of nitrogen? 1s2, 2s2, 2p3. Right? This is the valency shell. 2s2, 2p3 is the valency shell over there. So here 1s2 I can write it as helium. So the electronic configuration of the nitrogen in a simple way I can write helium 2s2 2p3, helium 2s2 2p3, right? Next, here phosphorus electronic configuration. Helium after we will get neon 3s2 3p3. In the valency shell here also you are having combination of the arsenic. Let us see. Here helium, neon, after that you will get argon 3d10 4s2 4p3, right? And next antimony, helium, neon, argon, krypton 4d10 5s2 5p3. Next helium, neon, argon, krypton, xenon 4f14 5d10 6s2 63. Here also in the valency shell you are having ns2 np3 electronic configuration only. As all of these elements in the outermost shell or in the valency shell, they are having only 5 electrons. These elements are known as the 58 group elements. These elements are simply known as the 58 group elements, right? Here, as these are having ns2 np3 electronic configuration, I told these are called as 58 group elements. In the valency shell, all these elements are having 5 electrons, so they are placed together in one group. As these are having similar number of electrons in the valency shell, almost all of these elements will possess all same chemical properties. But the physical properties of these elements differ from one another. That depends on the number of electrons present in the penultimate shell. That depends on the number of electrons present in the penultimate shell. So how many electrons are present in the penultimate shell? Penultimate shell electrons. This is the valency shell here, right? Penultimate shell electrons. This is the valency shell here. Here helium. Helium means having 1s2, 2 electrons. Here 2. Here, this is the valency shell. Before 3s orbital, you are having 2s2, 2p6. That means 8. Here what happens? 4s2, 4p3 is the valency shell. In the penultimate shell, you are having 3s2, 3p6, 3d10. That means 18. Here 18. Here also 18. So what happens? Due to the different number of penultimate shell electrons in the nitrogen and phosphorus, they will show little bit of different properties when compared with the other elements of this group. Are you clear? Are you clear, students? So please take. Students, can you please tell me the 50 group elements once? What are they? Nitrogen, phosphorus, arsenic, antimony and bismuth, right? These are the 50 group elements. What will be the relative abundance of these elements in the Earth's crust when compared with the other elements? What will be the ranking means? Here, the nitrogen is the 33rd most abundant element in the Earth's crust. This is the 33rd most abundant element in the Earth's crust. Here, phosphorus is the 11th most abundant element in the Earth's crust. Arsenic will be the 52nd element and antimony will be the 64th element and the bismuth is 71 ranking. So in Earth's crust, what is most abundant element of the 5th A group element? It's nothing but phosphorus is the most abundant element of the 5th A group elements, right? And next, if you want to write it in the form of a order, phosphorus is highly available element in the Earth's crust. So its ranking is 11th, right? Next ranking, nitrogen, and then as usual order, arsenic, next antimony, and then bismuth. This is the relative abundance of the elements in the Earth's crust. If you observe nitrogen, here nitrogen is present in the form of N2, nitrogen gas in the Earth atmosphere. Here around 78.03% by volume of nitrogen is present in the Earth atmosphere. What is the relative abundance by volume in Earth atmosphere, not in Earth's crust? 78.03% by volume. It is available, nitrogen is available in the form of N2 gas. Nitrogen is available in the form of N2 gas in the Earth's atmosphere. And next, in Earth's crust, how these elements are present? Generally, the nitrogen is present in the Earth's crust. Okay, the nitrogen is present in the Earth's crust in the form of nitrates. How it is available? The nitrogen is available in the Earth's crust in the form of nitrates. What are the examples for that? The nitrogen is present in the form of NaNO3, sodium nitrate. This is called as chili saltpeter. This is called as what? Chili saltpeter. Chili saltpeter. Next, it is also found in the form of potassium nitrate, KNO3. This is also known as Indian saltpeter or Bengal saltpeter. Next, it is also found in the form of calcium nitrate, CaNO3 taken twice. This is also known as Norwegian saltpeter. What is the importance of these nitrogen compounds or nitrates? Means mostly the nitrates and other compounds of the nitrogen are used as fertilizers and as explosives. What is the use of these nitrogen compounds, nitrates or other compounds means? These are mostly used in the form of fertilizers, and they are also used as explosives also. These are also used in the form of explosives also, right? Next, phosphorus. Mostly this phosphorus is present in the form of phosphates. How the phosphorus is available in the Earth's crust means phosphorus is available in the Earth's crust in the form of phosphates. The phosphorus is available in the form of phosphates. Are you clear, students? That is available in the form of phosphates. Generally, the phosphorus compounds or phosphates are available as apatites. Most important, remember, apatites. APETITES. What are apatites means? Nothing but the compounds having the molecular formula Ca3PO4 taken twice and CaH2. All the compounds that are having the molecular formula Ca3PO4 taken twice CaH2 are called as apatites or apatite family. Generally here X will be fluorine, chlorine or hydroxide ion. Here X is equal to either fluorine or chlorine or hydroxide. Based on that, different names are given. For example, if it is Ca3PO4 taken twice, CaF2, that is called as fluorapatite. Next, Ca3PO4 taken twice, CaCl2, it is called as chlorapatite. Next, Ca3PO4 taken twice, CaOH taken twice, it is known as hydroxyapatite. That is known as hydroxyapatite. Along with this, the phosphorus is also present in the form of aluminium phosphate also. Phosphorus is also present in the form of aluminium phosphate, whose molecular formula is AlPO4. What is the use of this phosphorus? Means the phosphorus is an essential constituent in the plant and animal matter that is present in the bones, in all the living cells. Especially if you have seen egg or milk, they are having phosphoproteins. And we know in all the biological systems for the production of energy, what happens? ATP is converted into ADP. Okay, when ATP is converted into ADP, then energy will be released. So ADP means, adenosine triphosphate. Am I right? ADP means adenosine diphosphate. So here when ATP is converted into ADP, we are getting energy. That means it is also having, as the name indicates, it's also having the phosphorus elements. And we know this is present in DNA and RNA also. And next, if we have seen the arsenic, so here arsenic is present in Relgor, ReAlGa, Relgor, and its molecular formula is As4S4. It's a sulfide and it is present as orpiment or piment. As2S3 is the molecular formula of orpiment. It is the molecular formula of orpiment. Next, stibnite. Antimony is present in the form of stibnite. Stibnite molecular formula will be Sb2S3. Sb2S3. Next, bismuth is present in the form of bismite. Bismuth is present in the form of bismite. Molecular formula is BiO3. Are you clear, students? Are you clear? Right. Just these are the availability of the 50 group elements in the Earth's crust. Right, ma? So shall I ask you a question? Try to find the answer. What is the general formula of the apatite family? What is the general formula of the apatite family? Right? Try to identify the answer. Right. Discuss about the general properties or physical properties of these 58 group elements. The first property, let us take atomic radius. The first property, let us take atomic radius or atomic radii. Anything we can say, atomic radius or ionic radius. All these things will be in the same trend. What does it mean by atomic radius? It's nothing but the distance between the nucleus and the electron present in the valency shell of an element is simply called as atomic radius. If the same distance is measured in an ion, that is called as ionic radius. Here what happens means, in 15th group elements, if we want to discuss about the atomic radius of the 15th group elements, if we want to discuss about the atomic radius of the 15th group elements. Generally, the atomic radius of the 15th group elements is less than that of the 14th group elements. The atomic radius of this 50th group elements or 15th group elements is less than the atomic radius of what the 40th group elements or 14th group elements. What is the reason? Already in a long form of periodic table you have learned, but I will remind you once again. While we are moving from left to right in the long form of periodic table, the number of protons inside the nucleus increases. That means the effective nuclear charge increases. When effective nuclear charge increases, automatically atomic radius decreases. Right, that is why the 15th group elements are having lesser atomic radius than the 14th group elements. Okay, tell me these 15th group elements once. What are they? Nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen, phosphorus, arsenic, antimony and bismuth. If we have seen the atomic radius of these elements, the atomic radius of nitrogen in angstroms will be 0.7 angstroms and the phosphorus will be 1.10 angstrom and arsenic will be 1.21 angstrom and antimony will be 1.41 angstrom and the bismuth is 1.48 angstrom. So what is the trend in the atomic radius of these 15th group elements? Simply you can say the atomic radius of the 15th group elements increases from top to bottom, right? Gradually what happened? The atomic radius is increased. So easily you can remember like this: nitrogen, phosphorus, arsenic, antimony and bismuth. So gradually what happens? The atomic radius is increased from top to bottom. Why the atomic radius of the elements in a group increases from the top to bottom we know. Already we have seen the electronic configuration of nitrogen. 1s2, 2s2, 2p3. That means in the nitrogen, how many shells you are having? First and the second shell. 2 shells you are having. Next, if you come for the phosphorus, another shell is getting added. Arsenic, another shell is getting added. Antimony, one more shell is getting added. Bismuth, another shell is getting added. So here what happens? The differentiating electron enters into a new orbital while we are coming from top to bottom in a group. As the differentiating electron enters into a new shell, the atomic radius increases from top to bottom, right? And now here if you observe, the magnitude of increase in the atomic radius, see, from nitrogen to phosphorus 0.7 to 1.10, that means almost we got 0.4 angstroms atomic radius is increased. From phosphorus to arsenic it is 0.11 angstroms increased. Here 0.2 angstroms around increased. Here antimony to bismuth just 0.07 angstroms, 0.07 angstroms only increased. So here from nitrogen to phosphorus, what's happening? Considerable increase in the atomic radius is observed. And after phosphorus, phosphorus to arsenic, arsenic to antimony, antimony to bismuth, the magnitude of increase in these elements is less. The magnitude of increase is lesser after phosphorus. What is the reason means in the electronic configuration you can see in these elements d orbital and f orbital in the inner shells are having electrons. Due to the poor shielding effect of the electrons present in the d and f orbitals in the inner shells are responsible for the less increase in the magnitude of atomic radius. Because if poor shielding effect is there, what happens? The expected increase in the atomic radius does not happen over here. Whereas in the case of nitrogen and phosphorus, considerable increase is there because they are having the electrons in inner shells only in s and p orbitals. They can offer more shielding effect. Next, let us discuss about the ionization energy. Ionization energy. What does it mean by ionization energy? Ionization energy means the minimum amount of energy required to remove an electron. What does it mean by ionization energy? The minimum amount of energy required to remove an electron from the valency shell of a gaseous element is simply called as ionization energy. Right? Are you clear? What does it mean by ionization energy? The minimum amount of energy required to remove an electron from the isolated neutral gaseous atom is simply called as ionization energy. Shall I repeat it again? The minimum amount of energy required to remove an electron from the valency shell of an isolated neutral gaseous atom is simply called as ionization energy. What happens to this ionization energy in 15th group? We know that the ionization energy is inversely proportional to atomic radius. Right? See, if an element is having only one shell, then what happens? That electron is very close to the nucleus. If an element is having 1, 2, 3, 4, 5 shells, the electron in the valency shell is away from the nucleus. That means the effective nuclear charge acting on the valency electron decreases. What happens? The effective nuclear charge acting on the valency electron decreases if the atomic radius increases. Then, if we expand less amount of energy, we can remove the electron easily. That is why the ionization energy is inversely proportional to the atomic radius. So in 15th group, what happens to this ionization energy means, here the atomic radius is getting increased now. So the ionization energy gets decreased from top to bottom. Nitrogen, phosphorus, arsenic, antimony and bismuth. Right? Next, what will be the ionization energy values of these elements? Nitrogen, phosphorus, arsenic, antimony and bismuth. These are the 50th group elements. The ionization energy value of this nitrogen in kilojoules per mole will be 1402 kilojoules. And phosphorus will be 1012 kilojoules per mole. And arsenic will be 947 kilojoules per mole. Antimony will be 834 kilojoules per mole. And the last one, bismuth will be 703 kilojoules per mole. If you see between nitrogen and phosphorus, the difference in ionization energy is very high. If you compare these three, the difference between the ionization energies are very less. Why? The difference between the ionization energies of arsenic, antimony and bismuth are small, or why they are having less difference in the ionization energy means simply this arsenic, antimony, bismuth are having electrons in d and f orbital. If we are having electrons in d and f orbital, these two orbitals offers poor shielding effect. Okay, they offers poor shielding effect. Due to the electrons in the d and f orbitals, due to the less shielding effect, they are having lesser difference in the ionization energy values. Right? Next, electronegativity. Right? Let us discuss about the next parameter, electronegativity. What does it mean by electronegativity? The tendency of an element to attract the bond pair of electrons. What does it mean by electronegativity? The tendency of an element to attract the bond pair of electrons is simply called as electronegativity. So here, what will be the electronegativity values of these elements? Nitrogen, phosphorus, arsenic, antimony and bismuth. What will be the electronegativity values means? It is 3 and next 2.1, 2, 1.9 and 1.9. These are the electronegativity values. Here antimony and bismuth almost possess similar electronegativity. What is the reason for the similar electronegativity or almost equal electronegativity of antimony and bismuth means that is due to the presence of F electrons in the bismuth. Due to the poor shielding effect of the F electrons in bismuth, they are having almost equal electronegativity values. So here what happens? The electronegativity in the 15th group elements gradually decreases and becomes constant. Here it is the nitrogen, it is the phosphorus and it is the arsenic, and antimony and bismuth are having almost equal electronegativity values. Next parameter I would like to discuss the fourth parameter, density. I would like to discuss about the density. Next I would like to discuss about density. Simply this density increases from nitrogen to bismuth, that I want to just remember. That increases from nitrogen to bismuth. And just one point I would like to add over here, which is very useful for you if you got any problems in physical chemistry. At STP, the density of the nitrogen, STP conditions, the density of nitrogen gas, will be 0.00125 grams per milliliter. Right, 0.00125 grams per milliliter. And the next property I would like to discuss is allotropy. What does it mean by allotropy? Nothing but the availability of an element in more than one form is simply called as allotropy. The availability of an element in more than one form is called as allotropy. Here among the 15th group elements, except bismuth, all the elements will show the allotropy. Okay, except bismuth, what happens? All the elements will show the allotropy. So here the nitrogen is having two different allotropic forms. Nitrogen is having how many allotropic forms? Two different allotropic forms. They are alpha nitrogen and beta nitrogen. Alpha nitrogen and beta nitrogen. Here the alpha nitrogen is having a cubic crystalline structure. Alpha nitrogen is having cubic crystalline structure. Alpha nitrogen is having cubic crystalline structure, and the beta nitrogen is having hexagonal crystalline structure. Hexagonal crystalline structure. Here you have to remember the transition temperature. The most important one you might have been asked a question is transition temperature. That means at what temperature one allotropic form is converted into another allotropic form. The transition temperature for this will be minus 238.5 degrees centigrade is the transition temperature for nitrogen. And next, phosphorus. This phosphorus is having various allotropic forms. Phosphorus is having various allotropic forms. White phosphorus, red phosphorus, scarlet phosphorus, white, red, scarlet phosphorus, and then alpha black, beta black, violet, like this. It's having various allotropic forms. And arsenic is having three different allotropic forms. Arsenic is having three different allotropic forms: grey, yellow, and black. Grey, yellow, and black phosphorus. Next, antimony is having three different allotropic forms: yellow and black and explosive form. Yellow, black, and explosive form. Three different allotropic forms are available for the antimony. Okay. Shall I ask you a question? Which element of the 5th A group is not having any allotropic form? Okay. What is my question? Which element of 5th A group is not having any allotropic form? What is that? Did you get the answer? That is bismuth. Bismuth is not having any allotropic form, right?